विद्यार्थी मित्रांनो, आजच्या आपल्या या लेक्चरमध्ये आपण यंत्र अभियांत्रिकीमधील थेअरी ऑफ मशीन्स या विषयाची तोंड ओळख करून घेणार आहोत. मी प्राध्यापक डॉक्टर आशिष विखार, वरिष्ठ अधिव्याख्याता, यंत्र अभियांत्रिकी विभाग, आपले सर्वांचे येथे स्वागत करतो. माझ्याविषयी आणि अशाच प्रकारच्या व्हिडिओ लेक्चर्सविषयी अधिक माहिती जाणून घेण्यासाठी तुम्ही माझी वेबसाईट व्हिजिट करू शकता www.drvikhar.com and I request you all to subscribe my YouTube channel Dr. Ashish Vikhar. What we are going to learn in this lecture, we will learn about what is theory of machines, what is mechanics, statics, dynamics, kinematics, kinetics. After that we will try to learn what is the meaning of machine and what are the functions of machine, and at last we will understand the classification of machines. Before going to understand theory of machines, introduction to theory of machines, we should know these concepts. What do you mean by energy, power, force, work done, mass, weight, pressure, velocity, acceleration, distance and displacement. You might have studied these parameters in first year of your course. So always any kind of thing starts with energy. Energy is having two types. One is called as kinetic energy, another is called as potential energy. There are different forms of energies available like mechanical, thermal energy, nuclear energy, chemical energy and all. Let us start how to differentiate between distance and displacement. In this figure you will see two houses kept apart by a certain distance. The road is joining to these two houses, and in this way distance is shown and as well as the displacement is shown. So distance is a scalar quantity and the total distance traveled by an object that is shown in this figure by a road, but the displacement is denoted with the dotted lines. So displacement is a vector quantity. The shortest path in a straight line between the first position and the second position is called as a displacement. Let us see the differentiations. Distance is the length of the path actually traveled by a body in any direction, while displacement is the shortest distance between the initial and the final position of a body in the direction of the point of final position. So this is fundamental difference between distance and displacement. Distance between two given points depends upon the path chosen, while the displacement between 2 points is measured by the straight path between the 2 points. So here the dotted line shows the displacement between the 2 points, point number 1 on the left hand side and point number 2 on the right hand side in this figure. So distance is always positive, but the displacement may be positive as well as negative and even zero also. Distance is a scalar quantity while displacement is a vector quantity. Distance will never decrease while displacement may decrease. So these are some of the points of differentiation between distance and displacement. In the same fashion, we can differentiate between speed, velocity and acceleration. What is speed? The distance that an object passes over time is called as a speed, while related to the velocity, it is indicating the distance of the speed, the direction of the speed. And lastly, what is acceleration? The velocity over time. By formula, if you see, speed is nothing but distance upon time, while velocity is also defined as distance upon time, but maybe it is a if you take the distance, then it is a sum of the distance, or subtraction of the distance. While acceleration is defined as rate of change of velocity upon time, it means final velocity minus initial velocity. If you see, speed and velocity is having the same units, meter per second or kilometer per hour, while acceleration is denoted with the unit meter per second square. No doubt earlier I have said speed is a scalar while velocity is a vector quantity, because speed does not depends on the direction while velocity depends on the direction. Acceleration, it is a vector unit, it depend on the direction change and velocity change are considered in defining the acceleration. So this way we can differentiate between speed, velocity and acceleration. Take the example number 1. A man walks 200 meter for 10 seconds to the west, then continue in the same direction for another 100 meter for the another 10 seconds. Then what is the speed and velocity of the man? By reading this problem, we can say that total distance is equal to 200 meter plus 100 meter is equal to 300 meter, while total time is equal to 10 second plus 10 second is equal to 20 second. So we can find here speed is equal to distance upon time. So total distance is 300 while time is 20. It means that 15 meter per second is the speed. While velocity, again you will see the same, because the distance is nothing but 300 meter. So 300 divided by 20, again we can get 15 meter per second. But by considering the second example, we can find the different calculation. What the statement is: a man walks 200 meter for 10 seconds to the west, then continued in the opposite or east direction, not in the same direction, for another 100 meter for another 10 seconds. What is the speed and velocity of the man? Now in previous example, the man walking 200 meter for 10 seconds to the west, then continue in the same direction, but the direction is reversed. In the second problem, the direction is opposite, that is east direction, for another 100 meter for another 10 seconds. Then you will see that total distance will be the again the same, 200 meter plus 100 meter is equal to 300 meter, while total time is equal to 10 second plus 10 second is equal to 20 second. But if you calculate the velocity, then we can say that the distance will be 200 minus 100. It means that 100 upon 20 is equal to 5 meter per second. So velocity is changing here 5 meter per second, but the speed is remaining as 15 meter per second. So from this we can analyze what is the difference between speed and the velocity. So speed is nothing but distance upon time, while velocity is nothing but displacement upon time. Speed tells us speed of the body, while the velocity tells direction of the body. Speed is a scalar quantity, velocity is the vector quantity. Speed is always positive, while velocity can be positive or negative. Let us see the difference between velocity and acceleration. Velocity implied on speed of an object, while acceleration implied on change in velocity. Change in velocity means final velocity minus initial velocity. This velocity means displacement upon time, while acceleration is nothing but velocity upon time. Velocity tells us speed of an object, while acceleration tells us change in the velocity. Velocity is having the unit meter per second, while acceleration is having the unit meter per second square. So this way we can differentiate between speed, velocity and acceleration. Let us see the difference between work, energy and power. Work refers to an activity involving a force and a movement in the direction of the force. For example, a force of 20 Newton pushing an object 5 meters in the direction of the force does 100 joules of work. It means 20 multiplied by 5 meters, force multiplied by distance, that is giving you the work. So 100 joules of work is done. Regarding energy, energy is the capacity for doing the work. You must have the energy to accomplish a work. It is like a currency for performing the work. To do 100 joules of work, you must expend 100 joules of energy. So this is the points of differentiation between work and energy. Let us see about power. power is the rate of doing work or the rate of using energy, which are numerically the same. If we do 100 joules of work in 1 second using 100 joules of energy, then power will be the 100 watts. So this figure indicates the difference between work, energy and power. Let us see the difference between force and power. Force may be push or pull type. Push or pull of an object is considered as the force, while power is the amount of energy transferred or converted per unit time. In International System of Units, the unit of power is watt, equal to 1 joule per second. Power is equal to work done upon time, or we can define it as a delta E upon time t. So work and power. Work done by a force is equal to the product of force and the displacement in the direction of force, while power of a source is the rate of doing work by it. Work done does not depend on time, while power spent depends on the time in which work is done. SI unit of work is joule, while SI unit of power is watt. Let us see the difference between energy and power. Energy of a body is its capacity to do work, while power of a source is the energy spent by it in 1 second. Energy spent does not depend on time, while power spent depend on time in which energy is spent. SI unit of energy is joule, while SI unit of power is watt. So this way again we can understand what is the difference between mass and weight. Mass is the measure of quantity of matter considered in the body at the rest, while weight is the force with which the earth attracts a body. Mass is a scalar quantity, while weight is a vector quantity. SI unit of mass is kg, while SI unit of weight is a Newton. Mass is measured by physical or beam balance, while weight is measured by a spring balance which is calibrated to read in Newton. Mass is constant for a body and does not change by changing the place of the body, while weight is not constant for a body but varies from place to place on Earth's surface, and also the altitude and depth from the Earth's surface. So these are the points of differentiation between mass and weight. Let us see the difference between force and pressure. The push and pull action resulting in acceleration of an object is called as a force, while force acting upon a certain area and acted upon something perpendicular to its surface is called as a pressure. Force is having unit in Newton and is represented by a symbol N, while pressure unit is Pascal and it is represented by a symbol Pa. Pa means Pascal. The instrument to measure the force is called dynamometer, while the instrument to measure pressure is called as a manometer. Force is a vector quantity, which means it also has a direction, while the pressure is a scalar quantity, which means it does not have a direction. Force can be acted upon on the face, edges, side or vertices of an object, while pressure only acts on the surface or face of the object. The velocity of an object can be changed with the application of force in one direction, while pressure on the object won't change the direction of an object. So these are the points by which we can gain an information about what's the difference between force and pressure. आता आपण शिकूया थेरी ऑफ मशीन्स बद्दल. थेरी ऑफ मशीन्सला टॉम असेही म्हटले जाते, TOM टॉम, आणि त्या शब्दाने आपण उच्चार करतो. हा मेकॅनिकल इंजिनिअरिंग अथवा यंत्र अभियांत्रिकीमधील एक अत्यंत महत्त्वाचा विषय आहे. यंत्र अभियांत्रिकीमधील हा विषय असा आहे जो यंत्रांच्या विविध भागांची गती, ज्याला आपण व्हेलॉसिटी और स्पीड म्हणतो, किंवा सापेक्ष गती ज्याला आपण रिलेटिव्ह मोशन म्हणतो, आणि त्यावर कार्य करणाऱ्या शक्तींबाबत माहिती करून देतो. ह्या विषयात यंत्रांच्या विविध भागांना कार्यान्वित करण्यासाठी जे बल म्हणजेच फोर्स लागते आणि त्यामुळे यंत्रांच्या विविध भागात जी सापेक्ष गती रिलेटिव्ह मोशन निर्माण होते त्याबद्दलची विस्तृत माहिती मिळते. हा विषय मशीनच्या विविध घटकांमधील सापेक्ष गती रिलेटिव्ह मोशनच्या अभ्यासाशी संबंधित आहे. यंत्रांच्या विविध भागांची रचना म्हणजेच ज्याला आपण डिझाईन म्हणतो, ते डिझाईन करण्यासाठी यंत्र अभियंत्यांसाठी यंत्रांचे सिद्धांत माहिती असणे अत्यंत आवश्यक आहे. हे यंत्रांचे सिद्धांत कोणते? तर यंत्रांचे सिद्धांत खालील 4 शाखांमध्ये विभागले जाते. पहिला प्रकार आहे कायनेमॅटिक्स. ही थेअरी ऑफ मशीन्सची ती शाखा आहे जी यंत्रांच्या विविध भागांमधील सापेक्ष गती म्हणजेच रिलेटिव्ह मोशनशी संबंधित आहे. यामध्ये एखाद्या यंत्राला कार्यान्वित करणे, नियंत्रित म्हणजेच कंट्रोल करणे आणि त्यातील विविध भागांना सापेक्ष हालचाल म्हणजे रिलेटिव्ह मोशनद्वारे कार्य करण्यास बंधनकारक करणे म्हणजे कन्स्ट्रेंट करणे हा भाग येतो. जसं इंजिनिअरिंग मेकॅनिक्समध्ये आपण शिकलो आहोत. इंजिनिअरिंग मेकॅनिक्स मीन्स स्टडी ऑफ फोर्सेस, बट engineering mechanics is divided into 2 categories. One is called statics, another one is called as a dynamics. Statics means study of a body when it is at the stationary position or it is at the rest position, while dynamics means study of body when the body is in the motion. So dynamics is again classified into 2 category. One is called as a kinematics and another is called as a kinetics. In kinematics there is a study of body when it is in motion and without considering the forces acting on the body, while in kinetics we will go to study the acceleration velocity with the consideration of the forces acting on the body. So in dynamics generally we measure mass, velocity, acceleration, distance traveled, such type of parameters, while in case of this statics we do not calculate mass, velocity, such parameters because the body is in rest position. So this way the first part of this theory of machine is kinematics. Secondly, it is called dynamics. ही theory of machine ची अशी शाखा आहे जी यंत्रांच्या गतिशील भागांवर एखादी क्रिया होताना वापरण्यात येणारी शक्तीच म्हणजे पॉवर व त्याचा परिणाम ह्याचा एकत्रित अभ्यास करते. गतिशास्त्र कायनेटिक्स ही यंत्रांच्या सिद्धांतांची अशी शाखा आहे जी यंत्रांच्या विविध भागांचे वस्तुमान म्हणजेच मास आणि गती म्हणजेच वेलॉसिटी यांच्या एकत्रित परिणामातून निर्माण होणाऱ्या जडत्वाचा म्हणजे इनर्शियाचा अभ्यास करते. स्टॅटिक्स ही थेअरी ऑफ मशीन्सची अशी शाखा आहे जी मशीन्सचे विविध भाग विश्रांती घेत असताना म्हणजेच कोणतेच कार्य करत नसताना शक्ती म्हणजेच पॉवर आणि त्याचे परिणाम इफेक्ट्स याविषयी माहिती देते. यामध्ये विविध भागांचे वस्तुमान मास म्हणजेच मास नगण्य म्हणजेच निग्लिजिबल मानले जाते. आता आपण बघूया मशीन अथवा यंत्र म्हणजे काय. कोणतेही मशीन हे असे उपकरण आहे जे उपलब्ध स्वरूपात असणारी एखादी ऊर्जा म्हणजेच एनर्जी प्राप्त करते आणि विशिष्ट प्रकारचे काम म्हणजेच वर्क डन करण्यासाठी त्या उपकरणाचा नंतर वापर केला जातो. मशीन म्हणजे यंत्रांच्या विविध कठोर म्हणजेच रिजिड आणि प्रतिरोधक म्हणजेच रेजिस्टन्स भागाचे संयोजन आहे, ज्यांचे सर्व भाग म्हणजेच पार्ट्स एकमेकांना अशा प्रकारे जोडलेले असतात की ते एकमेकांच्या निश्चित सापेक्ष गती म्हणजेच रिलेटिव्ह मोशनने फिरतात आणि शक्ती किंवा पॉवर प्रदान करतात. रिजिड बॉडी आणि रेजिस्टन्स बॉडी अशा 2 प्रकारच्या बॉडीजचा उपयोग थेअरी ऑफ मशीन्समध्ये केला जातो. रिजिड बॉडी म्हणजे अशी बॉडी त्याच्यावरती फोर्सचा काही परिणाम होत नाही, त्याच्यावरती कुठले डिफॉर्मेशन्स होत नाही. पण अशी बॉडी काल्पनिक बॉडी असते, एक इमॅजिनरी बॉडी असते. कारण असे एक्सपेरिमेंटेशन नुसार असे आढळले आहे की रिजिड बॉडी असली तरी त्याच्यावरती फोर्सचा काही ना काही परिणाम होतो आणि त्याच्यामध्ये डिफॉर्मेशन्स येतात. म्हणून ॲक्च्युली रिजिड बॉडीला काल्पनिक किंवा इमॅजिनरी बॉडी म्हटलेलं आहे. जी काही बॉडी किंवा जो काही भाग आपण अभ्यासतो तो असतो रेझिस्टन्स बॉडी. रेझिस्टन्स बॉडीमध्ये फोर्स अप्लाय केल्यानंतर त्याचे डिफॉर्मेशन आपल्याला बघायला मिळते. मशीन्समध्ये पॉवर इनपुट आणि पॉवर आउटपुट मेकॅनिकल, इलेक्ट्रिकल, हायड्रॉलिक, केमिकल किंवा न्यूक्लिअर पॉवर असू शकते. म्हणजे मशीन्समध्ये ज्या एनर्जीचा वापर होतो ती एनर्जी ॲज अ इनपुट फॉर्ममध्ये कुठल्याही प्रकारची असू शकते. मेकॅनिकल एनर्जी असू शकते, इलेक्ट्रिकल एनर्जी असू शकते आणि आउटपुटमध्ये सुद्धा त्याच प्रकारचं आउटपुट आपल्याला मिळू शकतं. मेकॅनिकल, इलेक्ट्रिकल, हायड्रॉलिक, केमिकल आणि न्यूक्लिअर पॉवर. उदाहरणार्थ औष्णिक इंजिन ज्याला आपण हीट इंजिन म्हणतो, हे औष्णिक ऊर्जा प्राप्त करते आणि त्याचे रूपांतरण यांत्रिक ऊर्जा म्हणजे मेकॅनिकल एनर्जीमध्ये करते. म्हणजे इलेक्ट्रिकल एनर्जी इज कन्वर्टेड टू मेकॅनिकल एनर्जी इन केस ऑफ हीट इंजिन. काय झालं?